Hey students, this is lesson 632, functions. In this lesson we're going to learn how to recognize functions and especially linear functions. Check out this definition of function here and see if you can see which set of these input-output tables represents a function. Go ahead and pause now. You can try that. All right, just a little bit of a review here. Go ahead and read the vocab and go ahead and do problems 2, 3, and 4. Pause now and you can check your answers. All right, so function is a relationship in which each input is paired with exactly one output. And sometimes functions can be represented in different ways. Check this out here. It says in the diagram below, what is the relationship between the figure number and the number of squares in the figure? And what you might notice is figure number 1, you start with 1 in the middle, and then there's 4 around the outside. Again, on figure 2, we have 1 in the middle, we have 4 like the first one, and then we have 4 more around the outside there. And this one has the first 4, the second 4, and then 4 more added on. So the relationship is the number of squares in the figure is 4 more than the previous number, or think of it this way, figure 1 we started with 1, and then for each figure we added 4 more. So on figure 3 we added 4 3 times. If you think, maybe think of figure 0 as having 1 square, and then you keep adding 4 more each time. So we have a constant increase of 4, so it's a linear relationship. And we can say that the next figure is has 4 more squares than the previous figure. And also thinking of this as a linear function, we can say that the number of squares is 1 more than the figure number times 4. So if we took 3 times 4 and then added 1, we would get the number of squares in the figure. And which means we could also represent this with a linear equation, which is what we're going to do in this next one. It says, is a relationship a function? In other words, is there one output for each input? And we can automatically see that that's true. None of these inputs, none of these minutes have more than one output. So yes, it's a function. And then it's describe the relationship using words in an equation. And what you might notice is that the number of gallons of water is decreasing by 12 each minute. So we're losing 12 gallons of water per minute. And then the equation we can use to represent this is y, the number of gallons, equals 440 minus 12 times the number of minutes that we are draining the water. Or if you wanted in slope-intercept form, we would just switch that around and put negative 12x plus 440. All right, I'm going to let you try that here. Go ahead and see if you can figure out whether it's linear, and if it is linear, write an equation for that. So all of these are linear functions because they go up, they increase in both variables by a constant amount. In the first one, the mountain climber starts at an elevation of 1,127 feet and climbs 92 feet per minute. In the second one, the total bill is at the grocery store is $52.07 plus $1.29 times the number of cans of soup bought. And then the last one, the number of gallons of gas in the tank is 1/17 times the number of miles traveled. Oops, I forgot something there. It's equal to 11.2 gallons minus 1/17 times the number of miles traveled. All right. Another way to identify linear functions is by looking at their graph. And obviously anything with a straight line is going to be a linear function. Anything that's not a straight line is a nonlinear function. Okay? So we're going to go ahead and graph this, and I'll let you pause it, graph it, and then check back. And then once you have the graph, look at it, and if it makes a straight line, we're going to say it's a linear function. it's not a straight line, then we're going to call it a nonlinear function. After you graph this, you probably notice the dots were lining up. And so this is a linear function. And it's actually a direct variation. We could write an equation for 2 centimeters is equal to All right, so this, you can see this is a linear function. When you put the dots on the graph, they all line up. And in fact, it's a direct variation, so you could write the equation y equals 2.5 for x. All right. Let's go ahead, you try that. Graph this and see if you think it's a linear function or a nonlinear function. You should have noticed it's a nonlinear function since these dots do not line up in a straight line. They kind of curve there. All right, problem 3, writing a rule to describe a nonlinear function. In this, we're just going to kind of have to guess a little bit and think about what we know about numbers. But check out these numbers, and I'm just going to write them in a table so we can analyze them a little closer. So we have 1, 1, 2, 8, 3, 27, 4, 64, 5, 1, 25. And if we knew what the pattern was, we could guess what the 6th one is. This is a nonlinear function because x is going up by a constant amount while y is not going up by a constant amount. So it keeps changing. So we know it's a nonlinear function. But the rule is there's something going on with x to produce y. And what you might notice is this. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, and so on. So the rule is, notice we're multiplying the number by itself 3 times. So y is equal to x to the 3rd power. That's the cubic function. Cube is the 3rd power. Go ahead, you look at this situation here, fill out the table, and see if you can't recognize what rule we can use for that function. All right, I hope you recognize that function. It's square numbers, so y equals x squared. Go ahead and do the lesson check here, and we'll start talking about that next time we meet in class.